Alright, so you can see where I separated each of these into different colors, so all of my work somewhat corresponds to the color. The green one, I just used transformations for. I knew that it was absolute value of x, which starts at 0, 0. And then the plus 1 means the absolute value just moves up 1. So that's where I knew the vertex would be at 0, 1 for that one. For this one, the blue one has an open circle, and it's to the left, and then the green one has a closed circle, and it overlaps. So I just filled in that dot. So if you were using pencil, you wouldn't even be able to see the outside ring being a different color. You just fill in that dot. And then over here, they're at separate places. I do have an extra dot on my purple one because I did it in pen, and then I put it in the wrong spot, and then I had to fix it. So just, there is an extra dot there by accident. Questions on this before we go on to the back? When you're ready to go on, you turn over your paper so I know that we're ready to go on. And then, hopefully this is recorded and up on the internet later. I need to go back and watch it. And if not, I'll go find my video from last year and somehow link to that one. Excuse me. Okay, on the back is a new function called the greatest integer function. Or you could call it a step function, if you ever heard that. Looks like this symbol with the 2 bars together. And what this means is find the greatest integer that is less than or equal to the number inside. So less than or equal to. So we look at our first example, -1. Remember, an integer is no decimal, no fraction. So is -1 an integer? Integer, yes. So what is the integer that is less than or equal to -1? It's -1 because it's equal to an integer already. Okay? The next question is, what is the integer that is less than or equal to -1/2? So is -1/2 an integer? No. So if you can't figure it out by just looking at that, I could visualize it for you here. Here's where -1/2 is on a number line. What integer is less than or equal to -1/2? Help me out. -1. Thank you. I can just call on people too. The greatest integer that is less than or equal to 1/10. So 1/10, I'm going to use my same number line up here. 1/10 is about here. Which integer is less than or equal to 1/10? Dominic? 0. Good. 1.5. 1.5 is about here. What integer is less than or equal to 1.5? Kennedy? 1. -2.1 is about here, -2.1. What is the greatest integer less than or equal to -2.1? Say it out loud. -3. A lot of people want to say -2 or did say -2 because it's like right next to -2. This is not like a rounding thing. This is take it to the lower number. So here's a table where you can just think about it with values. If I pick any values that start at 0 and go all the way through 0.9999999, well, not 0.9 repeating because that is equal to 1. But you know, I'll just say 0.9. 0 to 0.9, any of those numbers are going to be what? When you take the greatest integer less than or equal to? Less than or equal to 0.9. That'll be 0. If I plug anything in from 1 through 1.9, we're taking it down to the integer. What number would that be? That's going to be 1 because we're going down to the integer. We're going to the less than or equal to. So now we can maybe follow a pattern. Anything from 2 to 2.9 is what? 2. Anything from 3 to 3.9 is 3. So anything that falls in that range is going to have that integer. You can put negatives in there as well, but I'm just going to do the negatives by following patterns when I graph them. Now to graph these, I'm going to take this and scale it different, so I don't have to do as much, just so you know. There's a lot of graphing. I'm going to zoom in a little bit here. I'm going to count by halves. I'm just labeling some of these. To graph these, anything from 0 through 0.9999999 is going to have a y value of 0. So any of the x's that go from 0 all the way to 0.9 is going to have a y value of 0. So that is constant. That is an answer that is the same for all of those. So the way it looks like on the graph is we put a dot at 0, we draw a line all the way to 0.9999999, which I can't. So what I'm going to do is, it can't equal 0. I'm going to put can't equal 1, so I'm going to put an open dot at 1, because that's kind of where it ends, right before 1. And then if I do plug in 1, or 1.1, or 1.2, or anything through 1.9, now my y value is 1. So it's going to jump up, and it's constant until it gets to 2. Then it's going to jump up to 2, and it'll be constant till it gets to 3. Then it'll jump up to 3. I just kind of missed that a little bit. And then from now to the end of both sides of the graph, I am following a pattern. This pattern is not linear, but it's kind of like linear, where it's going up by the same amount each time, so you can just follow that pattern all the way out. You can see why it's called step function, because it looks like stairs or floating stairs, if you've ever seen those. Have they ever seen floating stairs? Google a picture later. Scale on one part but not the other. Oh, yeah, because somebody made a mess and didn't clean the last part of themselves. I totally do. It's sitting right over here. Okay, so now let's talk about the domain and range. Remember, the domain is all the x values. So left to right, or looking in our table, what x values can we use? What are we allowed to plug in our table? Everything. You can plug anything in there. We don't get anything out, but you can plug anything in there, all real numbers. Oh, lunch! Oh, I keep forgetting about lunch. We will continue.